Hello, my name is David, and I'll be going over this problem. Okay, so the thing that we want to do in this problem, we want to find the area of A as I've drawn it, and B as I've drawn it. Okay, so there are the functions, there are the polar functions. So to find the area, of course, we need to find an integral. Um, okay, so when we think of the area, let's try to find the area of, let's do A first. Why not A? So when we try to find the area of A, we're gonna use this function right here. Um, yep, this function right here. So let's set up our integral. Uh, so it's 1/2. That's the formula, and then it's gonna be, if we think of a line right here and goes out to here, then to here, then to here, it's gonna be on this line. So it's gonna be 2 plus 2 cosine theta squared. But you see, there's also a thing right here up to this point. And for this point, we're gonna need to set them equal to each other. But before that, you see that we don't want the area of B, we want the area of A. So we're gonna need to subtract it. We're gonna need to subtract the other function between those regions. So it's gonna be 4 minus 2 cosine theta, okay, squared. Um, okay, so now another thing, uh, now we want to find the limits of this integral. So I'm gonna set them equal to each other, and when they're gonna equal. So it's gonna be 4 minus 2 cosine theta is equal to 2 plus 2 cosine theta. And then when we solve for it, I'm gonna bring this 2, so it's gonna be 2 minus 2 cosine theta, 2 cosine theta. Bring this to the other side, so it'll be 2 cosine theta plus 2 cosine theta. And then equals 2. And then we're going to combine these two cosines, so it's going to be 4 cosine theta equals 2. And we solve for that, and this is going to be 1/2 cosine theta. And cosine theta is 1/2 at pi over 3. We could do other regions, but the way this graph is structured and where it intersects, yes, pi over 3 makes sense. So we can say from 0, because these functions should start from here. Oh, yeah. Yeah, we do it from 0 to pi over 3. Because if we have the angle right here, this is 0. And then we go up 3 units, 3 angles, like pi over 3 angles. And then we're going to have it. Okay, so now the only thing, we set up the most important part was the integral. Now let's solve the integral. So what I recommend is just expanding this whole thing. Be 1/2. So this should be 4 plus 4 cosine theta plus cosine theta squared minus, if we expand this, let's put a parenthesis right here. Let's put so that's gonna be 16, and then and it would be -8 cosine theta no, sorry, I'm sorry. So this should be, no, yes, it would be 8. and then this should be -8 again. So we're gonna have plus 16. Okay, and now we're gonna have plus 4 cosine theta squared. And I did make a slight mistake right here. It should be a negative. Sorry. Okay, so let's double check. So 4 times 6 is 16, then this, and then this. Yes, and then, yep. Okay, so now we can spread the theta. So now let's expand all of this. So this should be 4 plus 4 cosine theta plus cosine square theta minus 16 plus 16 cosine theta minus 4 cosine theta. Okay, so now we can combine like terms. So 1/2. Okay, so we can combine this term and this term, and that's going to give us -12. So these two are out. So now let's combine this term and this term, and that should be 20. Okay, now let's combine this term and this term, and that should be -3. Okay, so now that's good. So now we can just go across and integrate this. So it'll be 1/2 with the integral of this times -12 theta plus 20 sine theta (1/2). Now I'm just gonna do this one individually. I'm gonna take out this 3, so it's gonna be just a 3/2 cosine theta. And then we can use a half angle identity to reduce this. And this should be 3/2. And with the half angle identity, it says that cosine squared theta is the same thing as 1 plus cosine 2 times theta over 2. But if I simplify this right away, I can pull out a 4 from here. A 4, and then it'll just leave me a 1 plus cosine theta. Sorry, 2 theta. And now if I solve this, we're gonna have 3 to the 4th theta plus, we do a u substitution in the 2 theta, we can bring it out, and so I'll just show you. So u is equal to 2 theta, and then this is gonna be 2 theta du, and then to solve for it, we just need to pull out this 2, so it's gonna be 1/2, and 3/4 times 1/2, that's gonna be 3/8, and that's gonna be sine 2 theta. Okay, so now that we have all of this, we can expand this. So we're gonna have -6 theta plus 10 sine theta. There should be a negative right here. Minus 3/4. Look, I already distributed the 1/2, so I don't need to distribute the 1/2 anymore. And then minus 3 over 8. Oops, sorry, this is theta. Sine 2 theta. Okay, so that's good. So now we have our limits. So now let's plug in our limits. The limits is from, oh, did I not state them? Yes, it's from 0 to pi over 3. 0 to pi over 3. So now if we plug this in, we're going to have this 3, so it would be negative 2 theta plus the pi over 3 theta, that's going to be square root of 3 over 2. So square root of 3 over 5, because if we simplify this, minus 3 over 4, that those two 3's will go away, and it will just be pi over 4 minus, and then this 2 theta, it will be 2 pi over 3 square root of 3, and then in the unit circle, that should say that that's pi over 3 over 2. So pi over 3, sorry, square root of 3 over 2. Then we have 3 times that, which is 8. And then that should be 16 right here, as we multiply them. Okay, and now we have our 0. So our 0 would be minus, I'm going to do it right here so we can see the screen. So that 0 will take away the 6 over theta. That 0 will take out this, will take this out, I will take this out. So in conclusion, we're going to have this. So it's going to, if we combine like terms, it's going to be 4, it's going to be 8, 4, negative 8 pi, right? Yeah, because that was a pi minus 4, so that would be negative 9 pi over 4 plus this minus 3 square root of 3 over 16. And then if we plug this into our calculator, we can see, so we do negative 9 pi over 4 plus 5 square root of 3 minus 3 square root of 3 over 16. We're gonna get a number that's about 1.267, and that should be the area in that region, in region A. So honestly, the kind of the hardest part to this is doing the integral, but that just comes with practice. And okay, so now if we do for region B, it's going to be a little different. So for region B, so if we think how this is structured, so we start right here, we go to this line. I'm going to do it in the green pen. Go from here to here to here to here to here to here, and we keep hitting this one right here. So we're gonna actually need 1/2 from 0 to pi over 3 of 4 minus 2 cosine theta square. And then once we finish this one, we're actually going to need to change our integrand to 1/2 from 0 to pi. Yes, to 0. Oh, sorry, not to 0. To pi over 3 to pi. It should be 1/2 pi, but you could always double check in your calculator. If you're not 100% sure, you can always try to plug in numbers and see what you get. So if I do trace on my graphing calculator, so double checking with my graphing calculator, I see that it should be from 3 pi, because we want the area, we want this whole area, so it would be from pi to pi, and that would just be of the inside function, so it would be 2 plus 2 cosine theta squared. Okay, so now I think if you recognize something like this, honestly, I didn't do it in this problem, but I recommend integrating what you need first individually and then changing the limits on it, so you don't have to keep integrating, because I combined both of those functions. So if we do them individually, we're gonna have, if we just do this integral first, we're gonna have 1/2 0 to pi over 3. That's gonna be what, 16 minus 16 cosine theta plus 4 cosine square theta. Okay, so now we can just we kind of already went over how this is solved. So if this is just gonna be a theta, and then this is gonna be 16. Oh, it's just gonna be 8 because we distribute 8, and then sine theta, and then this one should be 4, and then that should turn into a 2. Well, if we turn all of this into a half angle formula, this 4, and then we distribute this 2, so it'll be a 2, and with the half angle formula we have a 1. So then we're gonna have theta, and then we're gonna have plus 1/2 sine theta. Sorry, for sine 2 theta. From 0 to pi over 3. Okay, so now all we have to do is just to plug things in. So it just be 8 pi over 3 minus 8 square root of 3 over 2 plus pi over 3 plus 1/2, and then this would still be square root of 3 over 2. And then if we simplify this a little more, this would be a 4 square root of 3 plus pi over 3 square root of 3, 4. And then if we plug a 0 in, this will go there, this will go away, this will go away, this will go away. So this should be the answer for the first half of the portion. And now if we do it for the other one, so we have 1/2 from pi over 3 to pi, and that was 2 plus 2 cosine theta squared d theta. And then if we do it from there, we're going to have, so it's be 4 plus 8 cosine theta plus 4 cosine square theta d theta. And then this is very similar to the last problem. So this is going to be 1/2, so this is going to be 2 theta plus 4 sine theta, and then we turn it to the half angle formula. It's going to be 2, and then we just come with this 2. This is going to be a 1, so it should just be plus theta, and then it should be plus 1/2 sine 2 theta. And okay, so now our limits is from pi over 3 to pi. So, okay, so we do the pi, so it would be 2 pi plus, this will go away actually, pi, and then this should go away. Okay, so now we have minus 2 pi over 3, and then this square root of 3, so this should be plus 2 square root of 3 plus square root of 3 plus 4 square root of 3. Square root of 3. Okay. So now, if we bring everything together, I'm going to write this right here. So it's going to be 2 pi plus pi minus 2 pi. Actually, we can, let's combine these two terms. So it'll be 3 pi minus 2 pi over 3 plus 2 square root of 3 plus square root of 3 over 3 plus square root of 3 over 4. And then we have plus. So now we do what we got in the first one. Trying to bring it. Okay. So this is my first. I'm not really used to working with this. So this should be 8 pi over 3 minus 4 square root of 3 plus pi over 3 plus square root of 3 over 4. Okay, so that should be our answer, but I'm gonna simplify it, and then we should be done. So we group all the terms together, so it will be group this term with all the ones that have 3's and a pi. So we do this, we should have 3, 8 pi plus pi minus 2 pi plus another pi, so I'm just going to put the 2. So this 2 should go away, and then this would be 8 pi over 3. So this goes away, this goes away, this goes away, and this goes away. Okay, so now, oh, and then we have another pi plus 3 pi. And then we have these 2, so that should be plus, we have this 2 and this 2, so it should be a half square root of 3. And then this 2 actually would be negative 2 square root of 3. And you can simplify it a little more, but you know, this is good for now. So the biggest thing about this problem is that you want to recognize the regions that they both, that they both intersect, so you can find the appropriate values to put it into your integrand. Yeah, and like that's pretty much it. You just gotta, like I said earlier, I recommend maybe doing the integrals individually, because once you do the integrals, you can just plug in their limits, and then you don't have to reevaluate everything like I kind of had to do. But I kind of did it just sake of practice, and just showing you in case you need more integral review. Okay, so that's pretty much it. Thank you.